We've got a predictions array, but now we need to get it in the Kaggle submission format. So that's what we'll be working towards in this video. Let's go make ourselves a little heading. Preparing test dataset predictions for Kaggle. And if we look at the sample submission, we kind of know what we need. We know we need an ID column, which is the file IDs from our test images. We know we need columns for each of the different dog breeds. And we know we need the prediction probabilities, which is what we've got at the moment. We've got an array with all of these numbers. We basically need to just set up our predictions probability array into a data frame like this, export it as a CSV, and then upload that to Kaggle. So let's write that down. Actually, we'll put a little link in here of what Kaggle wants. Evaluation, copy that. This is just what the sample submission has to look like. Looking at the Kaggle sample submission, we find that it wants our model's prediction probability outputs in a data frame with an ID column and a column for each different dog breed. Well, it's not really a data frame, it's a CSV, but we can be a little bit incorrect there in our wording. And how are we going to do this? Let's write ourselves some guides. So to get the data in this format, well, this is a testament to our favorite little graphic here of preparing inputs and outputs. So now we've worked with the inputs. We've saved and reloaded our trained model. Now we're making a bunch of predictions, or we have made predictions. We're preparing our outputs, more specifically preparing our outputs for Kaggle. We will create a pandas data frame with an ID column, as well as a column for each dog breed. And then we're going to add data to the ID column by extracting the test image IDs from their file paths. And then we're going to add data, the prediction probabilities, to each of the dog breed columns. And then we want to export the data frame as a CSV to submit it to Kaggle. This is what we're after. And probabilities is spelt wrong. Standard Daniel. Typo king. Some nice little full stops. All right, so the first step, let's go through and create a pandas data frame. We've had experience of this way back in the pandas section with empty columns. So we'll go preds df equals pd.dataframe. So just a standard nomenclature for a prediction data frame. Preds df, preds data frame or predictions data frame. Columns is going to be equal to ID plus we need a column for each different dog breed, so we'll do one list unique breeds. And I just want to show you what list unique breeds looks like. List unique breeds. So there we go. So if we added ID to that, let's give that a burl. ID, oops, trigger happy once again, plus, there we go, ID plus list unique breeds. That is some column names for us. We'll comment out that and we will check out the head of our preds df. Should be empty with just a bunch of column names. That's what we're after, ID and all of our unique breeds in order. We've done this. So putting in some emojis. All right, add data to the ID column by extracting the test image IDs from their file paths. I believe we have already done that, but what we might do is just do it again. Test file names. But the way we can get each ID is by we want to extract this out. So we could do a little bit of fancy regex on this, but I'll show you another way. Append test image IDs to predictions data frame. So we want to go test path. Well, did we already create test path? We did. Okay, wonderful. So let's get test IDs. So this is just the path to our test file. And test IDs is going to be equal to a list comprehension of os.path, and then what is it? Split text. I'll show you what this does in a second. Split text. And for path in os.listdir test path. That should be correct. How can I show you an example? os.path.splitText. We want to get test file names. 0. Will this work? There we go. Okay, so it splits off the last little bit of the path, but we only want this. So that's why we have to do it for just the test path. So we want to just go through this test folder. Now it's not going to show up here, is it? Because there's a lot of images in there and that'll take a long time to load in Colab. You're just going to have to trust me with what this does. Let's just see it in action anyway. Test IDs. Will this work? If in doubt, run the code. Alrighty. Actually, we don't need the JPEG bit. So what we're going to have to do, we only want the first element of each of these. So we're going to have to put a little 0th index there. And let's see what this does. That's what we're after, test IDs. I don't want a large printout there. So what I'm going to do is just go preds.df. So I'm taking my data frame from up here. I'm going to make an ID column with the test IDs. So just taking that and putting that there. A little bit of overkill running this cell 3 times, but that is all right. Let's check out the head of our preds.df, as we always do when we manipulate our data. Okay, so we've got some IDs in there. Now we need to just append all of our prediction probabilities for each dog breed. Now how might we do that? I want you to have a think about this for a second. What do we have? We have test predictions, which is an array of predictions probabilities. And what do we have that's a list of different dog breeds? We have unique breeds. Of course we do. So add the prediction probabilities. This is getting exciting. We're getting so close to being able to submit our first full-blown deep learning model to Kaggle. We've gone from head to toe. The whole process, the whole shebang. If you can't tell, I'm pumped. So this is going to access the preds.df of all of the unique breeds, so all of the breeds columns. And then we want to just set that, look how easy this is, to test predictions. preds.df.head. And we are done. Ladies and gentlemen, have a go at that. If we would compare that to the sample submission, of course this goes on for a lot longer, but ours is using the model we have built. The numbers are going to be different, but that's okay. Now let's export it to a CSV so we can submit it to Kaggle. How do we export Panda's data frame to CSV? We use to CSV, of course. We want to go drive, my drive. I'm going to go to dog vision, and I'm just going to save it as maybe full model predictions submission 1.csv. Or maybe we'll tell ourselves mobilenet v2.csv. And we don't want index. So index equals false. We'll go here. We'll just write what we're doing. Save our predictions data frame to CSV for submission to Kaggle. Is this going to save? Fingers crossed. Yes, of course it will. Now let's have a look in here in our files. Oh, maybe we've glitched out. We've just saved a CSV there. Maybe Colab's lost the plot on us. Give me a second for my Colab window to reload, and I'll be back once I have access to this folder. Okay, I'm back. So sorry about that little interruption in broadcast. It seems my Colab window decided to go bonkers. You see why? Because I decided to open the test folder. I need to close that. And I might have to pause it again. 1 second. All right, third time's a charm. We are back. So be very careful with folders that you open in your Colab window. If they're full of data, aka 10,000 plus images, it will freeze up your Colab notebook. There we go, full model predictions. Well, we can't really see the whole thing there. Oh, there we go. And that's just our CSV file there. So if we wanted to, we can download that. We do want to. So we'll just wait for that to go through. I'll speed up my video until this is fully downloaded. Alrighty, so this is fully downloaded. All I did was just click download and then waited for it to go. It took about a minute or so, not too long. This is about a 30 megabyte CSV. If we come to my downloads folder, if we come here, yeah, about a 30 megabyte CSV. So 10,000 predictions. Now we've got that, let's go to Kaggle. And we can go late submission because this competition has already closed. You can see my past one there, 5 days ago. So let's upload. I want to show you that this works. Open. I'm just selecting the CSV we just downloaded. It's going to go through, briefly describe your submission. Let's go transfer learning, that's what we'll call it because that's what we used. Transfer learning, mobile, net, V2, dog, vision, baby. And then we'll make submission and it's going to score it. Now there's something up with this. Oh, 20. So that would be our goal, is to beat this one on the next one. And if we go back to the leaderboard, see where we appeared, we'll probably find public leaderboard. Score 0. I'd be very skeptical of any Kaggle competition where people have score of 0. So what you can actually find out is you can actually jank or actually hack the score here. So don't worry too much about submitting to here on a late submission. Your next goal is just to reduce your own score. And if you want my example submission CSV, I'll just link this in the resource section. You'll probably get the same score as me. Our next step in this project, if we were to keep extending it and train a new model, would be to beat our original score. Rather than paying attention to the leaderboard straight away, is focus on when you first begin, beat your own score. So now we've seen how to make full-blown prediction for the Kaggle competition. But that's not our original focus. Well, it kind of was. I lied. Right back up the top. What's this notebook called? Dog Vision. So our problem is identifying the breed of a dog given an image of a dog. When I'm sitting at the cafe and I take a photo of a dog, I want to know what breed of dog it is. So it's likely you'll want to be able to make predictions on your own custom images. So rather than just images that Kaggle has given us in a test and training set, what if you had some images of your own dog, which I happen to have, or a dog that you saw at the cafe that looked really cute and pretty, and you wanted to know what breed it was, so you took a photo and you came back to your machine learning model in this notebook, and you're like, I want to see what breed of dog that was using my model. Well, let's have a look at how to do that in the next video, making predictions on custom images.